The implementation phase is the longest phase of the software development lifecycle. This is where the development team creates the software, first in small modules which are unit tested, and then in increasingly larger sets of modules, integrated together until the full system has been implemented. This work involves the entire development team and several development environments to build engineering software which is ready for validation. In the development phase, the software engineers use the design documents and diagrams to guide them in implementing the software application. This work is done by the entire development team, guided by the project manager. Each engineer begins work on their module in their own private development environment. Each module is coded, compiled, and unit tested to ensure it meets the requirements assigned to the module. Unit tests are small standalone applications which exercise a unit of code, invoking the code's methods and functions and monitoring the code's behavior. The unit test may also simulate external methods and objects the code expects to make the code act as if it was in a complete system. Unit tests are used to verify each unit of code is correct before it is integrated into the system. Code reviews with other developers may also be required to catch bugs early before system integration. Build scripts are used to control compilation and linking of the software into executable components and subsystems. The build scripts ensure the software is always built the same way, no matter who is building the system. Developers' source files are added to the scripts as they are completed, so they can all be built together as a single combined system. Many times daily builds are automated to find build issues early. These builds take place in the build environment, which has the approved revisions of all the build tools and software installed on suitable hardware. A best practice is for developers to update their individual development environments with the latest build modules often, to find integration issues as early as possible. As the software modules are completed, they are integrated with other modules in the system integration environment. Merging the individual software units of code into a single system allows developers to test the system as a whole, ensuring the individual units of code work together. The system integration environment will contain a copy of the system databases populated with test data. Integration testing by developers is not rigidly controlled. System integration environments may have mocked-up modules installed to simulate external systems or software that is not yet complete. Individual developers normally concentrate testing on their own modules integrated with the rest of the system, instead of exercising the system with a comprehensive set of tests that cover all the requirements. Besides testing the system features, the system integration environment can be used to do performance and stress testing to ensure the system can meet system-level agreement requirements. Software that has been built, integrated, and tested as a single system by the development team is sometimes known as engineering software because it has not yet been independently verified by quality assurance. While the developers are implementing the software, the QA team is busy preparing for the validation phase by setting up the test environments and determining how to verify each requirement in a test case. The software code, unit test, build scripts, database schema, and configuration files are all stored in the Software Configuration Management System, which controls access and tracks changes. The SCM system uses authentication methods to control access to the files it archives. Authorization schemes are used to restrict the files a user can access to those for their own project. This enables a single SCM system to securely archive files for multiple projects. The SCM system also keeps track of revisions to the source files, tracking the changes that were made, who made them, and when they were made. And it can be used to create named baselines, which capture the state of the code at a particular point in time. Baselines identify the exact code revisions which were used to build an application delivered to the QA team or the customer. This ensures an exact copy of a baseline application can be built and delivered from the files archived in the SCM system. Any documentation done by the development team during the implementation phase is contained in the source code itself in the form of comments. Comments are meant to be used by developers as they are reading the code to identify modules and subsystems, explain algorithms, state the file's author and revision history, and include a copyright statement identifying the company which owns the code. The implementation phase artifacts delivered by the development team are the files archived in the SCM system, along with the SCM tracking history and baselines. The source code will have been coded and tested, as well as system integration tested, as a complete working system. A uniquely identified baseline will be created to mark the software delivered to QA for validation. Building the engineering software for delivery to QA entails pulling all the files from the SCM system tagged with the baseline identifier, then using the build scripts which were pulled to build the system executables. These executables can be packaged in an installation program, which is delivered to QA. The QA team's work during the implementation phase results in the isolated test environments with all the required hardware and software for validating the engineering code. The development team is typically not given access to the test environment to ensure the only code being tested is the engineering code built with the baseline identifier. The QA test engineers will also produce a group of test cases. Each test case is a recipe for testing a feature or aspect of the application. It will include the steps necessary to set up the test, putting the environment in a known state, and steps to perform the test and the expected result. Each test case will trace back to one or more requirements. If the application passes the test, it is said to comply with the associated requirement.